Hello everyone, this is Namita Saxena and we will learn about IPsec VPN in this video. So what we will cover in this video are these topics. So we are going to learn what is VPN first of all, what is IPsec VPN, how does it works. Then we'll learn about the IPsec protocols because IPsec is a suite of protocols. We will learn about IKE, AH, ESP and the ESP modes. So by the end of this video, you will get to know what is IPsec, how the tunnel forms, what are the two phases, what happens in those phases, and how basically our data sent from one peer to another peer through a secure and encrypted medium. Okay, so let's start. So first of all, let me tell you what is VPN. So VPN, most of the people know that VPN is virtual private network. So when we use it, just a very simple example for you guys. Suppose you are working from home and you're working for some company, okay, and you're working from home. So you can connect your office network from any part of the globe just because of this VPN. Because so, like you have one client which is installed in your laptop, and that client would be connected your office network, and you can able to access the net office network, and that is basically a VPN. So in VPN, which is the virtual private network, it basically creates a secure and encrypted connection over the internet. Okay, because internet is an unsecure medium, so it will create a very secure medium over the insecure network. That is the basically your VPN. Okay, so now we will learn what is IPsec VPN. So IPsec VPN, as the name indicates, IPsec means Internet Protocol and Sec is security. So when we are going to provide the security over the IP protocols, that is known as the IP security, IPsec means IP protocol. So for this you have to learn the OSI model. In OSI model we have 7 layers and IP comes under layer 3, which is the data link layer. Okay, so IPsec VPN is basically, you can say it's a set of network security protocol, and it enables the very secure transfer of packets between your two systems over an insecure medium, which is your internet. Suppose this is A host and it wants to connect with the B host, and both are on the different geographical locations. So what we have to do, we are going to connect those two locations with the help of one secure tunnel over the internet, and means two peers will going to connect with the secure tunnel, and then our data would flow from that tunnel. So in the further video, we will going to learn what is tunnel, but before that, let's learn about the features, which is very important. Anyone can ask what is IPsec VPN and what are the features. So these 4 features you have to remember very carefully, that we have 4 features in IPsec VPN. First is authentication, data integrity, data confidentiality, and replay protection. So we will learn these 4 quickly. What is authentication, first of all? So as the name indicates, authentication means we are going to authenticate somebody. We are going to authenticate something. So basically the sender and receiver will authenticate each other to make sure that we are really talking with the device we intend to or not. So basically what it is doing, it is just verifying each other. It is just verifying each other whether the particular user is valid or not. So how it will verify? It will verify, we have 2 types, we have 2 kinds, you can say, through which we can do the authentication. So first is your PSK, which is the pre-shared key. Pre-shared key is nothing but a password You just generate a password at A end, and that same password should be there on the B end. Then only your data would be authenticated. Okay. So first is our pre-shared key, and second is our RSA signature. RSA signature is also, it's a kind of a, basically you can say, uh, just a medium to authenticate. So is it what it's basically a public key crypto system. Okay, so it's provided digital signature. It provided digital signature to the message or to the data, and same digital signature should be there on the other end. Then only the authentication would be there. Okay, so that is your first feature. Then we have the data integrity. So as the name indicates, what is data integrity? Integrity means like we are going to check something, we are going to validate something, we are going to provide the accuracy. Okay, accuracy, and there should be no modification. Whatever we are sending from one end should be received at the other end without any modification. That is basically the data integrity. So in the data integrity, hashing would come. What is data integrity? We provide the data integrity with the help of the hashing. Okay. So in the hashing, we have two types. We can do the hashing with the help of SHA, or we can do with the help of MD5 also. So basically data integrity would provide you the, you can say, a kind of a check. Okay, at a kind of a check to your data. Okay, and with the help of the hashing, we means your message would create a hash function, and that can be used to map data. Okay, so basically hashing is nothing, it's a process of transforming any given key into another value, and that hash value should be there at the other end. Their hash value should be there on the other end. If that hash value is matched at the other ends, then your data integrity would be passed, would be checked. Okay, otherwise data integrity would not be there. And which are the algorithms which provide the data integrity? It is the SHA, it is MD5. These are the algorithms which provides the data integrity. Okay. Okay, so so now the second point is your data confidentiality. Okay, so that data confidentiality means you have to provide your data, it should be confidential, that it should be confidential, means nobody can read it without the key, or without the key which sender sent. So basically, in the data confidentiality, encryption would comes under data confidentiality, and in it encrypt our data. Nobody except the sender and receiver will be able to read our data. Okay, so what happens in encryption? Basically, we are going to convert the plain text into the cipher text with the help of the algos, and those algos are DES, 3DES, and AES. Okay. Now, last is our replay protection. So replay protection means duplicate or resend encrypted packets. It means like you can say, it means a replay attack is a form of a network attack in which your valid data transmission is maliciously or fraudulently repeated or delayed. So if something is repeated or delayed, so we have to provide the protection to it, and replay protection will just provide a protection so that duplicate message will not be resent again. That is basically the replay protection. It means it protects us from the replay attack. So these four features are the very important features which comes under IPsec. So I hope you understand what is IPsec. Basically, it's a kind of a, you can say it's a kind of a protocol which provide us the security, which provide us the secure transfer of packets through with the help of that tunnel. Okay, and we have the four features under it. Now we will learn what is IPsec protocols. So IPsec protocol uses several protocols. Okay, it's a kind of a suite of protocols. Okay, suite of protocols, and it contains your First of all, the IKE, which is very important. And then we have two other protocols, which is AH and ESP. So in IKE is important because with the help of IKE protocol, only our tunnel would create, okay? And with the help of the two phases, our tunnel would create. So we are going to learn that what is IKE protocol and how the tunnel established. And these two protocol will help us when we have to encrypt the data. Okay, the data which goes from the tunnel, when we have to encrypt that data, comes under these two protocol will help us to do that. And IKE basically protocol which help us to form that tunnel. Okay, to form the tunnel. Tunnel means a very secure pipe, you can say, between the two peer. We have to create a pipe, and in that pipe only our data would flow, and it is encrypted. It is so secured that nobody can hack it and nobody can track our data. Okay, that's why we are going to use this IPsec protocol. So let's learn what is IKE. So basically, IKE, first of all, is Internet Key Exchange. Okay. So goal of the Internet Key Exchange is both sides to independently produce the same symmetric key. Means if you are not depend on anything, independently, it's produce the same symmetric key. So how it is producing the same symmetric key? This thing we have to learn. So basically, IKE builds the VPN tunnel by authenticating the both side, this side and this side, and reaching an agreement. So basically, it forms an agreement on method of encryption, integrity, and then that outcome of the IKE negotiation is your security associations. So very important thing which we have to keep in mind is security associations. Now, what is security association? Security associations is basically it's a kind of an agreement. Okay, first of all, let us make an agreement that I will take these things. I will use these protocols. Means I will use this protocol for encryption, this protocol for hashing, this protocol for authentication. Means both party will form an agreement. Okay, this is the agreement, we will work on this. That is the security associations. Okay, so basically IKE is a key management protocol. It generate a key, and that key should transfer at the other end, and key should be same at both the ends. Okay, then only it will negotiate. And basically, it used to negotiate our security associations. And I have told you that what is security associations? Security associations, nothing but an agreement between the two peers. It's basically kind of a policy, you can say. It's a policy for communicating. So the two peers can communicate with each other. It is basically the security associations. So basically, what IKE will do, IKE negotiate the security associations among the two peers, and then your tunnel would form. Okay. So the key which generate at this end, this key then encrypt and decrypt the regular IP packets between your two peers. Okay, so basically it is based on the ISAKMP framework. ISAKMP is Internet Security Association Key Management Protocol. It's basically a framework where security associations will negotiate between the two peers, and the key will generate, and that key should be there on the remote end. Once the key got matches, then only your tunnel would form. Very simple. So now two phases would fall under this thing. Let's learn what are the two phases. So in phase one, basically two peer will negotiate about the encryption, authentication, hashing, and other protocols. So all those protocols, it are basically the 5 parameters. So in phase one, basically what happened, it used to negotiate ISAKMP policy by exchanging the 5 values, 5 parameters. And that parameter we can learn like this, we can say haggle value. Okay, haggle value. H is hashing, A is authentication, G is group, means which Diffie-Hellman group you are using, L is lifetime, and E is encryption. Okay, we will learn these things in further slide. So what I told you, in phase one, our haggle value would exchange, and in phase two, your interested user data traffic would be sent. So in the phase one, see, see this thing. There are two peer with this one router one, and this is router two, where we are forming this tunnel. First of all, I would like to say that the tunnel would form between the two routers also, between the two firewalls also, okay? Whatever your medium is. So IKE phase one tunnel would establish, first of all, your security associations would negotiate, your IKE phase tunnel would establish, and after then, our phase two would establish. And in that phase two, our data would go. Our data would flow from phase two tunnel. Phase two, phase two. Okay. So one thing which we have to learn is in IKE phase one, basically two peer will negotiate the haggle value. Haggle value is hashing, then A is authentication, G is group, L is lifetime, and E is encryption. These 5 value will going to negotiate, okay? And in this phase, ISAKMP session is established, okay? ISAKMP session is established. That's why it's known as IKE phase one tunnel. So, basically what is hashing and all I just told you, but still let us repeat one more time. What is hashing? What is so hashing? Basically, we use hashing algorithm to verify the integrity. So for hashing, what we are going to use, which algorithm? MD5 and SHA. Okay, MD5 and SHA algorithms we are going to use. In authentication, what happens? Authentication, basically, each peer has to prove who is he, whether he is a valid user or not. It comes under authentication. Okay. So in authentication, RSA or PSK key, we are going to use for authentication. Then group. Group is basically the Diffie-Hellman group. Basically, it determines the strength of the key. What is the strength of the key? Is it good? Is it bad? Or is it excellent? So basically, it defines the strength of the key. Okay, that is used in the key exchange process. So the higher group number are more secure, but take longer to compute. So basically we use Diffie-Hellman group 14. Okay, other also group you can use, but I just given you an example. Then we have lifetime. So lifetime means how long does the IKE phase one tunnel stand up. Okay, so a default value is 1 day, but it depends to vendor, which vendor we are using, and it depends on that, and that is the lifetime. Okay, and the last is your encryption. Encryption means what algorithm you are going to use for encrypting your data. Okay, and that same algorithm same haggle value should be used at the other end. Then only your your tunnel would negotiate and can be formed. Okay, your phase one would negotiate. So that is about your phase one, where your haggle value would exchange, and then in phase two, your actual traffic, your interested data would flow from the phase two. Okay, so let me show you an example. Let me show you an example. I have one Wireshark log. Let me show you. This is one of the Wireshark log, and we can see through ISAKMP protocol that how the haggle value is exchanging. Okay, so see, this is a Wireshark log. We can see under ISAKMP protocol. I'm going over. See, under the payload, we can easily see here, see IKE, this is an IKE attribute. So under attribute, our Haggle value transfer. So in the Haggle value, so now we can see ISA KMP protocol, and in the ISA KMP protocol, we can see under the payload. See, this is the Haggle value which is being transferred, okay, to the peer end. How? See, the encryption is AES, which is going to use here. Then Haggle value, na, so H is hashing, a SHA algorithm is used. Then A, authentication, PSK, which is pre-shared key is used. G is for group, okay, group is used here, okay. Then we have L, which is the lifetime. Okay, we have the lifetime duration is 1 day, and E is encryption, which is AES 256. So now what we can easily correlate with, okay, that this is the Haggle value, and in the first phase the Haggle value would exchange, and in the second phase our original data would flow. Okay, so that is about the phase 1 and phase 2 and how the tunnel forms. Okay, now very important thing, that IKE builds the tunnel for us. Okay, so we have learned the IKE protocol, Internet Key Exchange Protocol. Basically, it builds the tunnel for us, but does not authenticate or encrypt the user data. Now, how our user data will encrypt? Okay, so for providing the encryption on the top of that user data, we are going to use the two protocols. We are going to use the two protocols. So first protocol is like your authentication, authentication header, and second protocol is your ESP, which is encapsulating security payload. Okay, so basically these both two are help, but both have different functions. How? So AH protocol is basically authentication header protocol. Okay, so basically what it ensures data integrity with the checksum that a message authenticate code MD5. So basically it provides the authentication. It provides authentication to the data with the help of MD5 or MD5 algorithms. Okay, so with the help of this algorithm, it basically provides a authentication. So one thing which we have to remember here, that AH protocol will only and only offer the authentication. Okay, it will not encrypt your data. So because of this issue, nowadays AH protocol is not using, because we need to provide the authentication as well as encryption to the data. So if you want to provide this thing, both thing if you want to provide, then we have this, which is ESP, encapsulating security payload. So in encapsulating security payload, basically, we are going to provide data confidentiality and the data integrity, data authentication to our data. Both the things we will going to provide, authentication also and encryption also. That's why we are not using AH nowadays. It is already superseded by ESP protocol, because ESP authentication encryption both are there. Okay, so let's see in ESP protocol what happens. Suppose this is our original data, which is having IP, which is the IP having IP header and payload. So what happened basically? Uh, one ESP one ESP header would insert before your payload, and it is completely encrypted. Okay, your plain text is completely encrypted into the ciphertext. Okay, and it also insert for next header. So it insert one ESP header and it insert one NH header. Okay. So in ESP, basically what happened, we have the sequence number which allow detection of replay attempts, one thing, and we have the SPI. Okay. We have SPI in which indicates that which security associations are going to apply. So basically what is SPI? SPI is security parameter index, and it is basically an index number indicating which security association is going to apply. It is known as the SPI. So this header would contain these two things, and next header would contain, next header field indicate the origin encapsulated protocol field. Okay, it contains the ICV. ICV is your integrity check value. It is a hashed message authentication code of the payload, the non-changing IP and AH header fields, and appropriate key. Okay, so it is basically the integrity check value. These things it contains. Fine. So let us compare both the things. I have told you there are two protocols which are going to provide the encryption and authentication on our data which is flowing from the tunnel. Suppose this is our tunnel and this is our tunnel, and we have provided the haggle value to just to create the phase one. And in phase one, our SA negotiation would be there, and then our haggle value would transfer and our phase one would create. Okay. But on the top of the phase one, phase two would create, and in that phase two, our interested traffic would flow. Okay. So in the interested traffic, if we want to provide the authentication encryption on that interested traffic, we are going to use two protocol. One is AH and second is ESP. And nowadays, ESP we are using mostly because it is providing authentication as well as encryption on the data. Okay. So see, this is your original IP data packet. In the authenticated header, how it become the authenticated header, it insert one AH header and the data would be authenticated. And then in the ESP, it insert the ESP header. So this data is encrypted also, and this data is authenticated also. So this watch is very important and using everywhere. Okay. Now, very important thing, there are two ways of using ESP. Okay, so ESP we are using in two ways. One is your tunnel mode and second is your transport mode. It's very important. Okay, so tunnel mode and transport mode, we can learn like this, that in transport mode, payload is encrypted, but not the IP header. I'm repeating it again. In transport mode, payload is encrypted. Whatever the data, that is encrypted, but your IP header is remain as it is. But in tunnel mode, your payload as well as your IP header both are encrypted. Okay, so this is much more secure as compared to transport mode. But both are have the different use cases, and accordingly we are using both the modes. So if you have to provide the secure communication between host to host. Okay, suppose this is your one client, this is your another client, and you have to provide the you can say security. So for this, we are going to use the transport mode. And if you have to provide the security to your data between the two gateways, then you are going to use the tunnel mode. Okay, so see, basically the transport mode does not authenticate or encrypt the IP header, okay, which might expose your addressing information to potential attackers while the datagram is in transit. This is important. Please, transport mode require less processing overheads than the tunnel mode, but it does not provide as much security. Okay, because in tunnel mode, our both the things are encrypted, your payload as well as your IP header. So just please concentrate over here. This is our original packet which contains IP, TCP data. So basically in your transport mode, payload is encrypted. This is your payload and it is encrypted with the help of ESP header. ESP trailer would insert over here, and it is fully encrypted. But IP is not encrypted, okay? In transport mode. In tunnel mode, your IP as well as your full data payload is encrypted with the help of this encryption. Okay, authentication is also provided over it, and here we will create a new IP header. So if our data would get leaked, or we have a new IP header, no issues. Now our original IP and payload would be saved because it is already encrypted. So this is the basically very major difference between both the modes which comes under ESP protocol. Okay, so tunnel mode create a new IP header. This is the new IP header and uses it as the outermost IP header of the datagram, followed by the ESP header and your original datagram. Right. So ESP trailer and the optional authentication data are appended to the payload. Okay, so when you use both encryption and authentication, ESP completely protects your datagram because it is not the payload data for the new ESP packet. So basically, ESP does not protect the new IP header, which I just want to tell you through all this thing. So right now, what we have learned, let us summarize. We have learned what is IPsec, what are its different protocols, and in IKE, we basically create the two phases. Two phases would establish, and our tunnel would establish under IKE, and with the help of our ESP protocol, which provide the encryption and authentication to that data which is flowing from the tunnel. Okay, so in the next video, what I will show you how we can configure the tunnel with the help of the configuration. I'll show you each and every configuration on FortiGate firewall. I'll show you just for an example and how the tunnel form. So thank you so much for listening this video. I hope this video will be helpful for you and you are able to understand the IPsec and its protocol. Thank you.